Boyle's law states that volume of a fixed mass of gas is inversely proportional to its pressure, as you can see in the animation. And the graph of Boyle's law is here. Charles' law states that volume of a given amount of gas is directly proportional to the absolute temperature at constant pressure. As the animation shows that as the temperature increases, the volume increases, and as the temperature decreases, the volume decreases. This is the graph for Charles' law. Gay-Lussac's law states that at constant volume, the pressure exerted by a gas is directly related to its temperature. And as we can see in the animation, as the temperature increases, the pressure increases, and as the temperature decreases, the pressure decreases. This is the graph for Gay-Lussac's law.
Hello everyone, I'm here Richa. Today I'll be performing my art integrated activity. Today I'll be checking if the egg floats in saline water or in tap water. Let's get started. Here are our materials. We have 2 glasses filled with water. One is tap water and other one is saline. I had poured some salt in it and had mixed it well. Here I have 2 eggs and I'll be adding it one by one in each of the glasses. Now gently lower the egg into the water and watch what happens. See what has happened. Here in this glass, the egg has settled at the bottom, and in this one, in saline water, the egg is floating at the top. Why? What's the reason? So guys, what do you think? What is happening? Here, the salt water is denser than the ordinary tap water. The denser the liquid, the easier it is for an object to float in it. When you lower the egg into the liquid, it drops through the normal tap and until it reaches the saline water. At this point, the water is dense enough for the egg to float in it. If you were careful when you added the boiled water, the tap water to the salt water, they will have not mixed, enabling the egg to amazingly float in the saline water. So guys, what we have concluded, the denser the liquid, the material will more settle in it. If the material's density is more, then it will settle at the bottom. And if the density of the material is much less than the density of the water, then it will float in it. As you can see in this experiment, in saline water, the egg had float in it. But in normal tap water, the egg has settled down. Why? Because its density is much more than the tap water. But in it, the egg has float because its density is much less than the density of the water, as I had added some salt in it. So guys, we have learned that more denser the liquid, the less it allows the material to float in it. Thank you. I hope you have learned a lot. Have a nice day.
Good morning everyone, my name is Siddhant and today I am going to describe a small discussion or a small meeting on how the differentiation works. Let's start. As you see in physics, these symbols, as you see earlier also, delta, differentiation, and which is used to denote the small change. And there, you see the velocity graph, velocity distance upon displacement upon time graph, which is developed velocity. As a car is moving with respect to time, it moves with a random speed. At every time of point, its speed is increasing, decreasing randomly. To find this random change, I want to find the speed of a car at that point. So I have to calculate on which distance, on the time period, and everything, and put the formula. And I have to find where the cars, what is the velocity of a car. But I on every point I have to find on this point, on this point, on this. I have to use this formula every time. But this method can be older, but a differentiation, a new method you can use to find this speed, this velocity of that object at any point without wasting the time and every formula. There are some rules of differentiation. Differentiation of a constant number is always 0. Differentiation of a function, a variable, is known as function. Any variable function, its power number is come in the front and the power is got 1 minus. Example, let the power is 6, differentiate, the 6 come in the front and the 1 power is minus. This is called differentiation. Add in product and division also. You can easily determine it. U dot means multiplicate product dv in final and initial velocity. We are doing this, and then plus at average particularly. But as in, there is an example, you see a division rule. The example, I take the u upon v in initial velocity upon final velocity in differentiation. That's the method. And now example, at the overall example, I going to differentiate this number. There is variable also, there is constant also, and how that it works. At there, I divide in two parts, this number and this number. That's come here, plus as plus, that's come here. As in the first law, we read that the differentiation of a constant number is always 0. Here is 0 comes, and there the 500, but it's with a variable, so it can't be 0. It's come as it is, and the x power 2 which comes here in the front with x, and x power reduce 1 there is. So the answer is 500 to x1 dx upon dy. This is the answer. And thank you. This is all the process of differentiating, and it is used in various things of physics, just like in gravitation and the other chapter also read earlier.
Art integration provides an interesting and effective way to understand maths and other subjects with more ease. We are able to connect different topics with each other and form a much simpler concept about them in our minds. It enhances our creative thinking and problem solving activities. For an instance, most of the equations we have in physics and chemistry are based on our maths. So often maths is also called language of physics and chemistry. So art integration is a good way to widen up our knowledge and building connection between different concepts.